Hello everyone, welcome back to iCAD's assembly tutorial. So it's been a long time since we did any other assembly tutorial. So we'll be starting with a simple one this time. So let's get started. So in today's assembly tutorial, I have taken this belt roller support assembly. The drawing that I have is an isometric drawing. You can download the drawing either from the screenshot, previously from the screen, or you can download it from the link below in the description. You can find all the drawings, 3D CAD and assembly drawings in the given link below. You can download and try whichever the ones you like. First, I will be designing the bracket. We require two brackets. So first, let me just do the one because we don't need the other one. You can just simply mirror the first one. So for this, first I will take top plane. Let's not take top plane. Instead, I'll take right plane. Okay. Now I'm gonna draw a rough sketch. Let's give it some dimensions now. And this is how much is it? 10 mm. And the overall from here to here, it's 35 mm. As you can see, okay. Now this is 8 mm. And we have one more thing, that is the overall height. Okay, let's take the height from here to here. This is 65 mm. Let's extrude this. We need to extrude this for, okay, this time we are going to extrude this from mid plane because it's symmetrical, and we need to extrude this for 48 plus 24. 48 plus 24, 72 mm. And the next is to cut the section from here, and I will take corner rectangles, draw the corner rectangles like this, and I need to make sure the midpoint with origin, make sure it's set to vertical. Okay, once that is done, the next is to give the radius. So I will take 3-point arc, and I will select first point with this line, second point with this line, and third point. Make sure it's tangential, and now you have to also make sure that this line is tangential with this line, right? So I'll just click on both the lines and give them the tangent relation. And the width of this, the rectangle that we have drawn, is 30 mm. This is 30. And you can see that it's still not tangential. That's because we have not given any relation with respect to the, we have given coincident, but there's no tangential. So click on this line and the arc, give them the tangential relationship. Do the same for this. Now it is properly defined, right? And one more thing we need to, we want to delete the outside, not the inside ones. So that's why I'll take the trim entity and trim this line and these two. Okay, you know what? Instead of trimming the lines, I will make sure I convert it to construction geometry because we don't want to mess with them, right? And once that is done, okay, Now what, instead of that, I realized there's error, so I'll just convert this rectangle itself into construction geometry. Now I'll again take line, draw a line like this. Now what you have to make sure is you give a relation between this. It can be either coincidental or it can be with a with some distance. I'll take coincident now, but if I take coincident, there will be two profiles that I need to select. And now why I'm selecting this coincident is because it will make my job easier. I don't need to give another dimension. And we see from the drawing that there is a fillet over here. So let's go to sketch fillet. I know I don't prefer sketch fillets, but this time I am choosing that. But I would generally, not prefer sketch fillets because it will just mess up your entire drawing. The fillet is 15 mm. That's one fillet. This is the second fillet. Why am I choosing sketch fillet is because if I don't use sketch fillet, basically I'll be adding one more fillet. And for this tutorial, I don't want that. So that's why I'm choosing sketch fillet. Now, and one more thing that is that's there. We'll do that later. Anyways, okay, so now we are done with the profile. Next is go to features, go to extruded cut, and here instead of band, it's through all both. And you need to select the contours because, like I said, if you give coincidental here, it will have two profiles. So first, my sketch profile is this. Since we are not able to do that, I will go back. Instead of collinear, I will give it some distance. Let's say 1 mm. I still have no idea why it did not work. Maybe there's some problem, or maybe I don't know something. I need to figure that out. I'll come back with the solution for that. Since we are not able to do that, it maybe is because of the thin section here, but I'm not sure. Anyways, I have now given 2 mm distance here. Now, as you can see, this shaded sketch contour, it's basically to make sure that the sketch is closed. Now let's go back to features, extruded cut. If your sketch is closed, you'll get that grayish blue mark. And instead of band, I'll choose through all and click OK. Okay, now it is done. The next is giving fillets here. I forgot to do that. It's 12 mm fillet in this corner as well as this corner. Done. And next is giving the rep or making the step. And one more thing is, I forgot that in the boss extrude sketch, I shouldn't have made it 35. Instead, it should have been 30 because there is a 5 mm step which I did not see. Now that I have, I've done the changes. Okay, let's do the step now. Take right plane, and it's a 5x6 rectangle. So I'll choose this. Go here, give it dimension. This should be 5 mm. And the height should be 6 mm. And we need it to extrude for 48 plus 24, 72 mm. Yes. And yes, we should merge this result. And next thing is, before I make the holes or ribs, there is another extrusion on this side. We know that it was already 8 mm extrusion. The overall extrusion of the particular circle that I'm going to draw is 13 mm. This is a 30 mm diameter circle. Yeah, and it is concentric with the fillet or the curl surface here. Now that I think there was one more way without using cut, I could have done this. I did not realize, I did not give it much thought at that time. So now we need to extrude this for 5 mm. not mid plane, but line, and 5 mm. So overall, this distance is 13 mm as given in the drawing. As you can see, it's 13 mm. Next is providing the rib. Go to right plane, select line. From this particular point to somewhere here, now you should give dimensions. The height of the rib that's given as 40 mm from the top of the base. So now let's go to features, select rib. The width of the rib is 10 mm. Yes, the direction is towards the body. Right click, you'll have your rib. The last step is providing the holes. There is two 12 mm holes. So let's do that first. Go to hole wizard and select 12 holes. Instead of ANSI inch, I'll choose ANSI metric, 12 holes. And it is 12 mm. Yes, it is through all. Now that we have, now we don't want near side countersink. Go to position, select this, and the hole should be concentric to the fillet. One hole and second one. Done. And there is one more here. Go to hole wizard and it's the same 12 mm drill hole. So basically it's we cannot give the same because it's on a different face. So for that we'll go to positions, and instead of selecting this face, we'll select this face, and again it is concentric with this. Done. So this is the first part. Now it is done. Let's save this. The next part, let's do the base, because it's again another important part of the assembly. We'll take again a right base, a right plane, and now we will just draw the half first and then we can mirror it later. It's like a stepped base. So something like this. I forgot to it's like this on the halves, and let's give it dimensions now. This is 10 mm. So is this. The thickness is constant, but the step varies. That's 10. And the distance from this line to this line is given, which is 3 mm. That's the step. Next, what else? The overall width of this is 120. So the half is 60 mm. And before we do that, what we should do is give this dimension, which is 96 divided 96 by 2. 96 by 2 plus it's not that, my bad, this is not the dimension. Okay, this is the first time I'm looking at the assembly. It's not like I've looked at the assembly and then doing the design. So this is 23 plus 12. That's what it is. And the this and this, these two lines are equal in dimension, so you don't need to give another dimension. You can just select these two and then give the equal relationship. Now we are done with the half. Now let's go to features, extrude this for 72 mm from mid plane 72 mm, or you can just do it, instead of making it two halves, you can just make one fourth of the design and then mirror it later. So let's do 1/4 instead. So instead of midplane, I'll go to blind, and it is 72 divided by 2, 36 mm. We are only doing 1/4 of the design now. Let's select fillet next. Fillet. This is 12 mm. 12. Done. And we need to give dwell hole. Go to holes. The hole is 12 mm, and we should give 4 since we are only doing 1/4. We should just give 1. Let's go to position. Select the face. And now we are done with 1/4 of the design. The next step is to mirror it. Go to mirror. Select the first face that you want to mirror it with, and the secondary mirror face is this. Now you can select two faces. Yes, before you couldn't do that, but since 2024 you can select two faces, two mirror faces. Instead of features, now we have to mirror body, because feature is not our concern. We have to mirror the 1/4 of the body itself to get the whole body. Select the body, make sure the merge results is clicked on, and click OK. Now your design base is ready. That's all. It's that easy. We made one more small mistake, which is this has to be 60. Make sure you change it to 60. I left it at 98 something, which was standard, which was, there. Now your design is ready. The third part that is there is the bushing. So we require 2 bushing, but you don't need to design 2 bushings. You just need to design 1, because this is the same bushing which the quantity required in BOM is 2. That's it. Now let's take a right plane again. Instead of doing all the cuts and everything, we'll just draw how the bush looks. This is how the bush looks. Now we need to give it dimension. Before that, I'll select center line and give a proper center line. That's the axis. Now let us start giving it dimension. So the internal diameter is, the hole is 18 mm. So it's 18 mm. As you can see now, it's not with respect to the center line, but it's the diameter itself. So when you select the line and then select the line, center line, you get half distance. But if you just come a little bit down, it is considering that as a revolved thing. So you don't need to give only 1/2 of the dimension. Next is the outer diameter is 30, which is 30. And this is 24. Done. Now the thickness of this is 3 mm. Oh, wait. The thickness, okay, I think I'll select, yeah. The thickness is 3 mm. Give it 3 mm thickness, and the overall is 21 mm. Okay, now we have everything ready. Just make sure this is now, just to make sure that I don't get a negative sign in the sketch. Go to features, select revolved base or boss, and now your bushing is done. That's all. The fourth part is the roller. So roller, again, we are going to use revolved base to create that. So for that, I'll take right plane again, and this time I will select lines. Instead of just making a construction line, I'll make an infinite construction line. If you just click on it and then select if you want horizontal or vertical line, now it's basically an infinite construction line. No matter how much you zoom out, zoom in, it's gonna be there. This is extended to the length of infinity, so you don't have to worry about confining it or giving it relation to the points or anything. Now next is drawing the basic sketch. 1, 2, 3, 4, 5, 6, 7, 8, and 9. If you look closely at the roller's isometric drawing, you can see a dotted line. So dotted line represents that's the That's how the section at that particular plane looks like. Now take smart dimension and start giving dimensions. This is 4 mm because overall is 8 mm, and the overall width is 40 mm, so this should be 20 mm, and the distance from here to here is 7 mm as given in the rollers drawing. Next is, and the distance from here to here is 9 mm, yes it is. So we know that the hole that is there is 24 bore, basically a 24 mm hole. So this is 24, and what else is given? Okay, from this point to the center, basically it's a 40 mm diameter circle, so it's 40. And from here, from that point, it has a 66 mm diameter. 66. Now we need to manually pull this up. And do we know the dimension of this? Yes, we do. So this is 70 mm. Diameter is 70 mm again, and the diameter of the outside is 76. What else? We haven't made this. Vertical. And we are missing with one more dimension, which is this is a 30 mm diameter. Alright, now it's done. Let's make sure this is now set to construction geometry, and select mirror entities in your sketch. Select all of this, right click and go to this mirror about, select this this line, and now your sketch is ready. All you need to do is go to features, select revolve base, this time select this axis. That's it. I'd say the last part is the shaft. Yeah, last part is the shaft. Again, shaft is a very simple part. All you need is revolve and then a few chamfer. That's it. Let's select right plane for that. And I'll draw the basic sketch first, like always. 1, 2, 3, 4, 5, 6, and 7, 8. Now the basic sketch is done. Next step is to give the dimension. The overall length is 80 mm, right? And this is 15. This is another 15. And this is 50. You don't need to check that. Even if you do, it's always be 15 because we have already given 3 dimensions to our drawing. And next is setting the diameters. The outer diameter is from, this is 12, is it? It is 12 mm, so it's 6 here, which means this line has to be collinear with this line. So let's give that relation. And the outer diameter is 18 mm, so basically the half of which is 9. And you can only drag your dimension when you have an axis line, or a construction line, not a solid line. Don't try to do that with solid line. And there is, however, a 6 mm drill hole. We will give 6 mm drill hole here, or we can just give, like what we did with roller and bushing. Okay, now it's done. Let's go to features. Features, revolve boss, and select that line. Done. Next step is giving chamfer. Go to fillet, drop down, chamfer. It's at 2 mm chamfer with 45 degree. So basically it's 2 mm here, and we're gonna keep the 45 degree as it is. Select this edge and this edge. It's done. Next is giving the drill hole, 6 mm drill hole. There are two 6 mm drill holes. One is through this and one is like this. First we'll do go to hole wizard. Select, okay, yeah, everything is set. Just we need to change it from 12 to 6. Positions. This is our position. Yeah, origin is our point. Done. That's for our first dwell hole. The second dwell hole is in the front right plane. Select hole wizard. Go to positions. Here select the right plane. Right? And this time we don't know the midpoint, so take center line here. Draw a line from this edge to this edge. And now select the point. Click. That's it. Done. The second dwell hole is done. So that concludes our part design of belt ruler support. The next step is to assemble them. Let's open assembly and import all the required parts into our assembly. Insert components. Select all the design design parts. Open. So when you're importing, the first part that you see in your document is basically fixed in your assembly environment. You can change that, but usually that's how assemblies work. So that's fixed, and whatever the parts that you select afterwards are floating parts. Basically you can move them wherever you want, but the first part you cannot move because it says the selected component is fixed. It cannot be moved. And how do you know if your component is fixed or not? Is basically you can see an F in a bracket prior to the part name. As you can see, it says bracket F part 1 bracket, right? Which means my bracket part is now fixed in the geometry. I cannot move it. Even with this, I cannot move it because it's fixed. Now, how to unfix it? Right click on that particular part. You can see float. If you select float, now you are free to move your part wherever you want. So now none of the parts are constrained, but ideally you should have one part fixed. In this case, what I'll do is I'll take the base as my reference. So I will fix the base instead of fixing the bracket. Next thing is to select the mates. We'll do this the normal way. I'll go to mate, and now this has to be coincided with this. Done. And the holes has to be concentric. If only one hole is concentric, what happens is it can move like this. So we don't want that. That's why select this. You can see this smart mating option. Select concentric. Now your second mate is also concentric. And we need to mirror it, right? Since we need the same thing on this side, we can either mirror it or we can use copy with mates. So before that, we need to make sure all the other things are mated as well. Select mate, and this has to be concentric with this. The thing is, the overall width of this, overall length of this bushing is 21 mm. Okay, that is fine. First is now this has to be coincided with this. Done. Now we need the same over this side as well. Now instead of, what we'll do is we'll take copy with mates, search for copy with mates. If you have a desktop version, you can find it here in the drop down option of insert component. Since I don't have it, I have to search for copy with mates. Select this. Now select the component that you want to copy with its mate. So go to next. As you can see, I have two mates option here. First is the concentric. I'll select the same cylinder hole, cylindrical hole. The next is coincident. I'll select this instead of that. As you can see, I get preview of how my copied part with mates will look like. If everything looks good, click on OK and close the copy with mates, because we only need one copy of that. We don't need two. So now I have everything ready. Next is we need this to be coincided with this. I'm sorry, not coincide, concentric. Done. And the next thing what we do is, now it's concentric, but it should be at the center. What we'll do is, before trying that out, we will first use copy with mates again. Copy with mates. Select the bracket this time. Select. Now first coincident is the the flat face. So I'll select this one because we don't need it on this side. We want it on the other side. And the next is selecting the concentric mates. We want it to rotate at 180 degrees. So this time, instead of the same hole on the other side, it's the opposite one. And the second one is this. As you can see, now we have our copied part. Right click and now close this, because we only need one copy of that. The next is this particular thing has to be concentric with this. Give it concentric relation. Next is it's as you can see here, it's not exactly at the center, so we need it at the center, right? Because if it's not at the center, then what's the point, right? I mean, I can do this here or here, but it doesn't look good for an assembly, right? So what we'll do is we will just move this along. Go to mate, and instead of standard, go to advanced mates. Select this width mate. Now when you select the width mate, select the two faces of the first component, and then in the option 2, select the two faces between which you want the first component to be in. When you do that, your object will be at the center of the second selected faces. So I selected these two faces. Now my object is at the center. Do the same for the shaft as well. Advanced width mate 1 and 2 and 1 and 2. Done. Your assembly is now complete. That's all. And you can still see this negative, in the brackets prior to your prefix to your names. That's because all the concentric mates are still movable objects. You can still move it like this. So if you want your concentric mates to not move, right click on the mates, make sure you click this lock rotation part. When you click that, all the concentric rotation will become fixed. So you cannot move or you cannot rotate the part around the concentric mates. But if you don't want that, if you're okay with the rotation, make sure you unlock these rotations. Unlock rotation, unlock rotation. And whichever the one with filled blue color thing in the mate option, that means it's a log. The rotation